Hello, welcome back to the channel. Today we are going to be embarking on a fun little journey to take these raw materials and this nib, or nibs like it, Yovo nibs, and make a fountain pen. I'll be showing you guys how I do my sleeved wood and resin hybrid pens. Over the last couple months I've been slowly changing up my methods as I've gotten some new tools and whatnot, and I think I've finally landed on a process that I'm very happy with. This is a piece of Osage orange. I had done a little bit of finishing on it previously just to kind of see what it looks like. You can see a little bit of that, there we go, chatoyance that it'll have in the finished sections there. But this should be a nice little combo. That streak should go away. I believe that's just on the outside of this blank. So this will be a fairly simple pen overall. We're using a little bit of aluminum can for the thin aluminum accents that we will have between the resin and the wood. And this will just be a very simple build overall, just mostly going into the basics of how I do this. You can definitely step things up with things like this pen here, which I just made recently. This is some Hawaiian curly koa with crazy fiber, micarta type stuff, and then some black ebonite as well for the sleeving and the threaded portions. This pen takes a Con 70 converter as it's feeding a vintage Omas nib, which came on a piston filling pen, so it doesn't have a little housing or a nipple to put a converter on. But while this is a very fancy pen, we'll be doing something a little less involved than this guy overall. I may at some point do a full video on a build similar to this, but that won't be today. So join along. We're going to go over to the lathe and get started. I'm going to do a little bit more prep on this and just get this ready off camera for putting onto the pen, but I'll tell you what I've done once we get to the point that this shows back up. So we'll catch you in a moment. Alrighty, okay. So we're back here at the lathe and we will be getting started on this guy. Get some of the gunk out of the way here. I think for a little contrast, I'm going to go ahead and make my section out of this orange. We'll do everything else for the resin stuff out of this, and then we'll have our Osage orange. So we'll set this guy aside for now, since we don't need to test fit for a moment. But I think the first thing we're going to do is go ahead and knock this guy out here. And the first thing we'll do is kind of true things up on one side, face it off, and then we'll measure our overall length, cut it off, do all of our drilling and threading, and just finish that up. I'm going to go ahead and actually time-lapse the entirety of making this section. Since it's a fairly straightforward process, I'm not doing anything that I haven't done on video already. If we do need a more in-depth video on how to do this, feel free to leave a comment down there letting me know, and I can do a step-by-step of each particular part of the pen. But there are also videos out there already for that. So I'm going to hop over to some time-lapse real quick for this particular portion, and then for the most part, everything else I'm going to film in real time, maybe speed things up, but this should probably be the only actual time-lapse portion of the video. So catch you guys for some talking when we're done. All right, there's our little orange section roughed out there. Not a big fan of these like super cheap converters. I really like the Schmidt ones, but we're opened up to about 7.5 millimeters in there, so plenty of room for converter. And yeah, this should be good to go. Feels nice and secure. Threads are tight, but not too tight. So yeah, I think we are in good shape. All right, so next, what do we got to do? Well, put this to the side. Put this to the side. Usually I go to my body next, so why not stick with what we typically do? One of the new things that I've gotten that I'm sure everybody is aware of if they've been keeping up with the channel is the new Turner's Warehouse stainless steel mandrels. I love these. They're incredibly rigid and really make for a solid platform for shaping and for especially doing the sleeving for the pens the way that I do. So we have about a 76 millimeter distance right here. So typically I recently have been taking an 80 millimeter slice, slightly over to compensate for having to clean things up, and then using that as the basis for the sleeve here. So overview of the process, if you don't feel like watching all of this and want to skip to the next spot, I'll try to do some chapters in this if you would like. This is going to be, I'm guessing, quite a long video. So what we're going to do is drill and thread our resin as we would normally make a standard all resin pen. Then after we have done that drilling and threading, we're going to stick this in the chuck. We're going to put our drilled and threaded blank onto the mandrel, and then I'm going to turn down the smaller diameters. In the past, I have, as a solid chunk, turned down the smaller diameter and then glued everything together and then drilled and threaded everything. That's a relatively simple way to do it, but the problem that I've found is you start to run into wobble and a lot of inaccuracy. And so far, I have found this to be a much more reliable way to get concentric pens, or at least get concentricity between the resin and the wood, so that I'm not accidentally like busting through the wood on one side of the pen as the resin inside is going like this because things got glued a little wonky and drilled a little wonky. So doing things this way has so far, from what I can tell, greatly increased the quality in the pens. So we'll go ahead and go through that here. We'll mark off our 80 millimeters, 81 maybe, and start doing our thing. I'm not going to make you guys watch all of this real time either. Obviously, if something is going to be quite boring to watch real time, we will be speeding it up, but I do want to get a good idea, or a little bit more concrete of an idea of how long these pens take me. Because I do have a good estimate in mind, but I always forget to actually like time myself when I'm working on this stuff, so. Alrighty. Now, I will say, a lot of, this is not a how-to video. This is definitely a how I video. This is how I do things. A lot of turning and life, realistically, is risk management and assessment and looking at what risks you are willing to take. What I'm about to show you and what you kind of maybe saw in the time lapse of the section is not necessarily a recommended way to part things off, but I don't have a bandsaw, and this is the best way to get a negligible kerf. I'm anchoring against my rest, and at no point in doing this do I ever feel out of control of the situation. Use two hands to kind of help pressure that through, and then as we start getting close, just light pressure on this guy. Until you're through. Now, not all materials are as friendly to this as resin. Wood, micarta are not quite as easy to do. You do have to do a little bit of a sawing motion with those. Acrylics I have found as well. If you don't feel safe doing something, don't do it. That's all there is to it. I feel safe doing this, so this is something that I do in my shop. You do not have to do in yours. Recently, I've been enjoying a 7mm tenon for the threads on my pens, for the cap threads. So we'll go ahead and mark that out real quick. Perfect. And then we're going to drill our pilot hole for our tenon cutter. That is a 6mm hole that goes down like 66 or 68 millimeters, so that you have enough room for the guide rod on the tenon holder, or the tenon cutter. And one of the other recent changes that I made to my process, because I ran out of the mineral oil that I had before, is I've started using Tap Magic for my drilling fluid, and it has greatly increased the quality of the drilling that I'm getting, with better heat management, better chip extraction, and you can drill further into the blank for longer before you have to stop and back out. I still like to try to do that more often than I would necessarily think I should, just to make sure that we're not tearing things. Although for these pilot holes, it doesn't really matter. Then once you get to a certain point, again, if you feel comfortable, you can just leave the lathe running and just move the tailstock in and out. This is nice because you can kind of feel that you're centered or not based on whether you feel any wiggle in there. And it's fairly quick. You may need to switch colors. This blank is like just on the cusp of the 19 and the 20mm. There we go. That should hold much more securely. One thing we're usually looking to avoid seeing when we pull this back out is a bunch of like dust buildup in here. Having these nice shavings is what we're after, because that means we're getting a nice clean cut. All right, that should be deep enough to cut our tenon. Now, the tenon cutter is not perfect. So far, in my experience, this one, I don't know if it's just my lathe setup, I don't know if it's this particular cutter or the bushings that I got, whatever it is, this one doesn't always give me, a 13mm tenon on my 13mm bushing, which is what we're shooting for here. A lot of the time it's a little larger, so I've just taken to making sure that I measure before I do my threading, and it has been working out pretty well. How you use this is fairly easy. It comes with a bunch of these setup bushings, where this is made to slide over and allow you to, yeah, that's okay. I won't turn it for you. There's a little cutter head on this side that this lets you get that kind of perfect spacing. And it's not quite perfect, but it does a good enough job. And in a single pen setting like this, it's not actually a huge time saver to use this. I like using it in most situations as of now because it's less fiddly and tedious for me. I drill a hole, I put this on, and then this does things for me. I don't have to spend 5 minutes taking a pass, checking, taking a pass, checking. It's just it's a lot less tedious for me. If it's not working for somebody else, totally understand not using it, but I don't mind taking the extra time to do the drilling, especially because I have recently started drilling pilot holes and then boring things out and getting much better results in drilling out my wood. So that's part of what has driven the, if you've been following me for a while, increase in price is these pens are taking me a lot longer to make, doing things in a better way. So yeah, the end result is more expensive, but it is also a much better quality overall, especially with having a much lower chance of blowing out material and losing material because of non-concentricity. So we've got our M13 by 0.8 triple start tap and die. I do like to go slow when I'm doing this because you can sort of tear things out a little bit if you're going too quickly. That is one of the reasons why single point cutting your threads on the lathe is a much cleaner way to do things overall. And then come on now, bud. I don't usually do this, but I'm going to give it a shot on this one just because I've noticed recently that these are a lot easier to take in and out of the holder. But I have seen a lot of folks recommend that you all right, cool. That just cuts things a little closer to the shoulder and makes sure that you are full depth all the way around. One thing I do kind of like to look at is just see if the height of the ridges is changing as I move this. Looks like they're pretty consistent all the way around, so that's nice. Now, where certain tools like the tenon cutter really come into play is going to be in batching things. It's a lot quicker to get everything drilled real quick and then run that tenon cutter through. Now, see how nice a tight fit that is. These taps and dies for the triple lead are very expensive. They're $300-ish a piece, so I do try to keep those in particular places and safe. All right, so we need 2 steps, 2 diameters for drilling our body. The first one is going to be the diameter for our threads. Those section to screw in. Those are about 8 millimeters long. The tap that I use is not a bottoming tap, so I usually try to go a little bit further. 12 for that is usually pretty solid, and that gives us enough space to have the full threads that we need all the way down in. So mark that. That'll be good. Then we want to do our .8 millimeter bit. And that's going to go all the way down into the very end to make sure that we have enough space. So we need about 76 millimeters. That, which I believe is marked already in my previous one. And yes, although I am just going to freshen that up so we know how far we need to go. Now you can do this 8 millimeter all the way down first before you do that 9 millimeter. It doesn't matter too much for this one. For the wood, I have really been having a hard time not wanting to do a 7.5 millimeter pilot to start. It's stiff enough to not get knocked around too badly by the grain, but small enough to give us a lot of room to work with if we do get off center a little bit. And then I like to go up in 1 millimeter increments for the boring part. And I do mean that in both definitions of the word. It is long and tedious to do the drilling this way in the wood that I'll show you, but it does provide a very, very nice end result. And this process of drilling and then slowly reaming out the inside is called boring. Now, when we're drilling that pilot hole, we can leave the lathe running and move things in and out. I've found that's kind of a bad idea if you are boring things out like this, because there is a tendency for the drill bit to catch and want to grab itself and pull in. There's a little bit less of a tendency to do that when you're drilling full diameter. And so many things being sequential in this process is why it can be tough to scale this up without large investments in large amounts of machinery. It's hard to even half the time that it takes to make one of these pens when you're batching. So that's why you don't usually see a huge, bulk discount when looking at custom pens. An M10 by 1 tap and die, or tap to match the M10 by 1 threads on the section. I didn't feel it bottom out, but that's not necessarily a bad thing. We should have plenty of threads in there for this guy. And we do. And would you look at that? Perfect little actually before we take that out, we want to make sure that we have this guy good. And it looks like but I'm going to relieve the inner bit here just a little bit more. Much better. Okay. All right, so especially if we turn this down a little bit, you can see that there is quite a bit of wobble. Part of that is because I didn't like fully true this blank up before starting. And should I have? Probably, yeah, but it's kind of tedious and I don't really enjoy doing it. So I just have to deal with that sometimes. One of the things, like I said, that I really like about these Turner's Warehouse stainless steel mandrels is they're very rigid. Typically, would not be able to clean up the end quite as easily and chatter freely there. All right. This is where the kind of a little bit of a nerve-wracking portion of this comes into play. Right now we got an 8mm hole down the center of that. And to make sure that we have plenty of space for doing the taper like I like to do for shaping my pens, we are going to want a 10mm outer diameter on about half of this length here, and then a 12mm for the rest that we don't want exposed here. So how do we do that? Well, usually a nice sharp tool and gritting our teeth and just a steady hand. Part of the reason that I had not been doing this prior is because you really need the rigidity that these stainless steel mandrels provide to be able to do this without having a lot of chatter. My previous Delrin mandrels could not do that.
So for the first little bit here, you can hear that chatter. The first little bit here, I'm just getting about the tool widths or the insert widths down, and we're going to bring that down to the 10mm. Then we're going to bring up our tailstock. The reason I'm not bringing the tailstock up yet is because I don't quite have the room to not hit the tailstock with the tool while working on this end. So we're going to knock that out first and get that down to our 10mm before we move on to tailstock support. Alrighty. For the most part, I do not have a particular distance that I bring this up. I'm mainly just bringing it up far enough that I feel that as I'm tapering the wood, I'm not going to accidentally go through it. And then the rest will be 12, or just under 12, so that we have room for glue in there. Now again, there's no particular distance that I'm going here. It's more so just how much of this do I want exposed. And for this one, I'm gonna say not a lot. Let's go maybe like, right now we're at 14.75, let's go like 12 to 10. Let's go 10mm of this exposed. Make ourselves a little line. Alrighty. And there we have the insert.
The insert for our body. This will allow us to eyedropper this pen if we would like. It'll make sure that if there's ever like a leaky converter or something like that, that all of that ink is contained inside of the pen. Periodically, I do accidentally drill a little bit too deep and make this divot a little too deep. You do get a hole through there. However, in the gluing process, you're going to fill that hole with epoxy, and typically it's not too much of an issue. So one thing I am definitely going to do real quick is just score this up a little bit. This just gives the epoxy a little bit of extra texture with which to grab the resin when we glue things together. Yeah. So yeah, we've got our 12 millimeter diameter here to give strength. We've got our 10 millimeter diameter here to give room for tapering. We still have about a 1 millimeter wall thickness here between that 8 millimeter inner diameter, 10 millimeter outer. I found a full millimeter is usually nice and strong for just about any materials. Once you start getting down to like a 0.5 millimeter thickness, it can be a little dicey, but depending on the material, it's not too bad. I've had some projects with 9 millimeter depth or 9 millimeter diameter holes, 10 millimeter outer, and they're holding up fine, but that 0.5 millimeter can be a little bit scary to work with sometimes. So, all right, next we want to, I think, go ahead and get our wood cut so that we can drill things for the body. All right, so we have this lovely piece of Osage orange. We're gonna need at least, I would say, this much for our body. Doesn't leave us a ton for our cap, although I do have more of this if absolutely necessary. But we'll maybe do a little embellishing with our cap if we actually need it. I think we'll have a short enough section here that we should be okay. Maybe make this a clipped pen if we have to. So give ourselves about that much space. That should be plenty for give ourselves a few extra millimeters. That should be plenty for parting off, and we'll just have to kind of keep in mind that we have a longer or a fairly short bit there to make sure that we don't accidentally, start our end tapering here and accidentally, cone off the end. This stuff smells like barbecue when you cut it. It's kind of nice. It gives us probably about 51 millimeters to work with for our top. That should be enough. Now, I have used Osage orange before, and it is kind of a pain in the ass to work with. It's very hard, and if I remember correctly, it didn't like to drill for me the last time I used it. Alright, I think I only want to take this in like 5 steps. We'll start with an 8 millimeter bit, move on to a 9, 10, 11, 12. Oh, it's 64 millimeters of depth that we need for our deepest portions. And then this is where things really start getting kind of boring. We're going to spend probably the next 25-ish minutes slowly making sure that we drill this out without heating things up too much, hopefully without cracking things, and whatnot. This is actually drilling a lot nicer than I remembered it going, and we are keeping quite straight. One of the things that I've been doing a lot of recently is working with burl wood, and drilling burl is a nightmare sometimes because the grain goes every which way, which makes it very pretty, but it can make drilling a little bit messy as the bit wants to try to get pushed off to various sides by the wild grain direction. So far, this fairly straight-grained Osage is pretty nice. There's a teeny bit of wobble in the bit, but not really too bad. Part of the reason that we slightly undersize our outer diameter for that is not just for a little bit of room with the glue, but also because sometimes those holes aren't quite fully straight in there, and so that extra little bit of wiggle room can make sure that things stay unbound as you're putting things together. All right. Next, we'll move up to our 9mm at the same depth. And I will say, having done this a few times now, this method, I have had a couple pens where my pilot hole was pretty severely wobbly, and by the time I got to the max diameter I was drilling, we were pretty much completely concentric and straight. So while this definitely takes considerably longer than just taking your max diameter and drilling it, this will result in a much more centered hole a lot more often. We're getting a little hot there, so what I think I'm going to do is go one more pass, and then I'm going to go take a break for a little bit, let this cool down. Actually, no, that little bit of cutting fluid may have helped. Let's finish this pass to full depth. Then we'll take a break. Alrighty, lovely. We're gonna let things cool down. That wood is toasty. And I'm gonna let my phone cool down. It's been recording for, I think, 45 minutes now. Almost an hour. All right, so we're gonna take a break and come back to this in a minute. But as you can see, we are an hour into making the body, and we're about a third of the way done with drilling this. We then have to make our holes in our aluminum and get everything assembled and glued. So kind of a long process, but thank you so far for sticking with me, and I can't wait to show you guys the end product when we do finally finish. All right, we are back to continue our drilling on this. This was our 9mm. We got 10mm to go for our full depth, and then we will be swapping up for the 11 and 12. don't like doing a ton of like cutting fluid on wood typically, but it is good sometimes. Just to help reduce a little bit of friction, especially as you start getting a little bit deeper. The next bit, go a little deeper than we need to here, usually by a millimeter or so. Call it 29. And again, that's more so just for room for glue to move around in there as we are adhering everything together. My lovely girlfriend is home. Let me finish this and I will come back to you guys in just a moment. All right, let's go. We're back. Doing some drilling. What are we doing right now? I think we're done with this one. It's a little tight. Yep, we're done with that. I think before we finish this. Oh yeah. No, I did finish it earlier. It was fun. I went to go test fit this and I think it's a little tight. Usually have some stuff in there. And no, that's actually perfect. So I think the tightness that I was noticing when I test fitted just before going upstairs when my girlfriend got home earlier was just from there being debris down in there. So that is a perfect fit. Not too tight, but enough that that'll be, you know, fairly concentric and everything when we glue it together. The next step to get this body fully ready for gluing up though is going to be drilling a hole in this and getting that all glued together. Now, the ideal way to put a hole in this is going to be using a metal punch. I don't have one of those yet, so I will be drilling the hole. To do that properly with material that's this thin, you need to securely clamp it between two pieces of sacrificial material and then drill through all of that. So I'm going to go ahead and do that off camera because I don't have a good way to set that up for where my drill press is. And yeah, easy enough. Put a hole in here so that we can glue it on. Those bits are gluing and we shall move on to the next, which is going to be our cap. So we're going to do the same process. Basically, we're going to put this M12 guy away. Get out our M13 in a moment here. Now, it's going to be basically the same process that we did for the body. We're going to drill everything out, then put it on the mandrel, trim things down, and then do our gluing and whatnot. We don't have quite as much wood as I would typically like for this, but I know we have a 7mm tenon for our body threads or cap threads. This is about an 8.4mm tenon here. So if we just make sure that we measure from this and make sure that everything fits from the back of this tenon here, we should have plenty of room in our cap for our section and our nib. So we need a max depth of minimum, I would say, 63mm here. Give us a little bit of space there. So on the Turner's Warehouse mandrels, and one of the few things that I have mentioned in the past that's not my favorite about them is on the caps here. If I can get it out, there we go. On the caps, you have a pretty long section of support there. This is great if you do short sections, because then you can kind of fit everything into, this one drill step. But I kind of actually prefer a stepped inner cap. I will be stepping this, but not quite as much as I normally would. Typically, I would like to bring the step down to where it meets with the front of the section and gives you a nice stop in there, so that you could, if you would like, maybe have no step up on your body. But as is, I will need a little bit of step on the body so that I have a positive stop for those threads, and you're not just coming to the end of threads for the cap to finish seating. So these have a minimum necessary depth of 52 millimeters from the shoulder here to the end. So we'll be doing 52 millimeters at the necessary diameter for doing our threads, and then we'll do a small step down for the remainder of the section area here. As you can see, there will be a little bit of the nib that will need to go past there, and so we'll step that down a little bit, since that doesn't need to be the full diameter, and we'll give us a little bit of extra meat for doing the shaping and whatnot. The nice thing about this is we will be able to, so I think what we'll do is maybe make this a clipped pen, since we have plenty of resin for doing that with. And in that vein, we will maybe leave 15 or so millimeters of exposed teal resin on the bottom here. Then we'll have our wood, and we'll have a little teal finial. Let's give ourselves, we don't need a super long piece for this portion, because we're going to have a finial going in for the clip. I have noticed that if I don't give myself a little extra space over just that minimum depth, then it's not quite enough. So I think what we'll do is we'll go up to like a 65, a little over 65 millimeter bit, and that'll give us just a teeny bit of extra wiggle room. Okay, so we do want to go all the way through this portion of the leg. We can do that now, or we can do it later. It's probably a good idea to just go ahead and do it now, get all of our threading and everything done, and then I do always have a little bit of a struggle sometimes deciding how I want to do things, so please bear with me. No, we don't want to drill all the way through just yet. We will wait to do that until later, after we have glued things together. So for now, we are going to drill this out in order to get it onto the mandrel so that we can do our turning exactly how we had done with the body. But after we do our glue up and get everything else trued back up, we will flip things around, drill out for our finial for our clip, and we'll go from there. So let us start some drilling. For this one, I think we will start at, we can start at like 9 millimeter for this. We'll do a 9, a 10, an 11, and then a 12.2. The 12.2 is necessary to not put too much wear on your tap and die, or tap in this particular case, when cutting. But for now, we're going to go to a depth of, I think probably the best thing for now will actually be to just go the depth for the mandrel. So we'll just go like 54. Yeah, 53 and a half. Just a little extra room in there. Now, it is fine to just drill these in one go, especially on resin, like that's okay. I have been finding that I just get better tolerances out of doing things this way and boring things out. Yes, it does take extra time, but I think the improvements are worth it. I could definitely be going full depth right here, and I could probably actually have skipped that last step, or be skipping this step between this one and my actual last one. But like I said, doing things this way is just a good habit for me to be getting into. With resins, drilling that full depth really is almost never a problem. However, I have been working a lot more with acrylics recently, and you can definitely have issues with full diameter drilling into acrylics. Just last week, I had a couple muck-ups where one of them was because I drilled the through hole on a section at 9/30 seconds, which is the kind of max diameter that you want to go, and I did it a little bit too quickly, and it ruined that section because the acrylic tears out sometimes when you're going too quick, or drilling a little bit too hard at max diameter like that. I've been having much better results by boring things out and letting just those outside cutting edges of the bit do their work. And this very last step here, we're only going in a couple millimeters. This is just our relief for that first little bit of threads for when we're starting to cap, so that we can have our nice quick cap and uncap. Forgot to grab our, well, we didn't forget. Our body is upstairs, so we won't be able to test fit that. However, this is kind of the most important one at the moment. And that fits in well and has pretty much no wobble. So, perfect. Let's just check our other thread leads. No wobble there. No wobble there. Perfect. So I think I had mentioned earlier, in general, I do try to shoot for at least a millimeter wall thickness. So a 2 millimeter difference between inner diameter and outer diameter. Inside of this right now, we have a 12.2 millimeter diameter hole. I'm going to do a 14 millimeter for this thicker part, and then we're going down to a 12 millimeter down here. Now, we are going right now this deep with the 12. So we don't really need to do a whole lot of 12 millimeter here. In fact, we're probably only going to want to do 55 and a half. That'll give us a couple millimeters to mess with there. We'll actually even give ourselves a little extra and go to 56. Now, this may seem a little pointless, and it might actually be, but this will give us a little bit of extra room for our, this is going to give us a little bit of extra room for our tapering near the end, since we are going to need to taper this for our clip. Because I think I am going to use one of my Mackenzie Penworks clips for this guy, and we'll leave that exposed at the top to kind of match the aluminum between our other bits. So we are going to turn up to this line a 12 millimeter section, and then we'll bring our tailstock up and do a 14 millimeter down the rest of this. And when I say 12, I do mean just enough under 12 that you have a little bit of, room for glue in there. All right, for this we're going all the way through. So we'll start with our 8 millimeter. We'll go all the way through up to 12 millimeter, and then we'll do our partial depth for the 14. And with that, we're going to take a moment and let this thing cool down. And I'm going to let my phone chill for a moment. We've been at this for about 45 minutes. So I'm expecting to be, another 20 minutes, maybe half hour or so to finish everything here and be able to get to gluing on the next piece. So I'm going to go grab a drink and hang out for a minute and let everything cool down, and we'll be right back. All right, let's keep it going.
Just make sure, do a little bit of lube here. I think that was my fault for accidentally bringing my quill back too far. I don't think that was just the tinker failing. We are going to 40 on this bit here.
We're almost there. This is feeling very hot though, so I am going to stop again and we're going to let this cool down. Alrighty, let's finish this off real quick. One of the things that I've found is as you get these walls a little thinner, you do tend to get a little bit of compression. Yeah, this boring can take a little while and it can be a little boring. But it has been the best way to get these holes to the correct diameters. I don't really want to have to do this here at the moment, but we're going to let this cool down one more time and give this a little bit of lubrication so we can get to that final depth that we need there. Alrighty, let's try to get this done. We'll add a little bit of cutting fluid just to hopefully help things slide a little bit better. And then last but not least, 14 millimeter to the same depth. I found that the 13, 14, and when I have to do it 15 millimeter, don't always like to drill terribly well. They're a little finicky as there's a lot of surface area in there getting engaged at once. Excellent. Ideally, this should just fit in perfectly now. Oh, yes it does. Beautiful. It'll give me half a second, I'll be right back. I gotten this piece drilled up previously. Whoops. I made the wrong piece. So I need to make one more of these with the correct. I just took this out of the drill press. Whale. I need to make another piece, so I'm going to go ahead and do that. It's really easy. I just, like I said earlier, clamp this between two blocks, drill a hole, or clamp a piece of aluminum between the two blocks, drill a hole, and then we're good. I maybe did not actually drill the full depth that I needed to for this, so we will figure that out. But the next time you see me, I will have some glued together pieces to move on to the next bit. So we'll catch you shortly. Alrighty, and we have our glued together pieces. All threaded, ready to go. On this end, what we'll do is, once everything is cured, we will trim everything down here a little bit and get this back on the mandrel and trim this end down to get that glue off and flush things up. And then we will go back in from this side and drill all the way through with our 9mm, and then do a little bit of 10mm just to give the nib some space. And then we'll be able to thread that for the finial. So I think this is going to look pretty darn nice overall. But I'm going to call it a night, and we will pick this back up tomorrow, which will be in just a couple seconds for you guys. But thanks for coming along so far and sticking with it. So catch you soon. Good morning. We are ready to get back to it and finish this thing off. So I think the first thing I'm going to do is, well, we had this very, very centered previously. So I think let's stick this back in, see how it looks and feels, which is a little off at the moment. We'll kind of adjust this guy in here until it's running. One thing I usually do, if I plan on getting something back into a particular position, is marking an index point on it. I didn't do that for this, so oops, but that's okay. That's not quite going how I would hope, so we're going to just go ahead and toss a mandrel back in. Now we have a little extra wood on the end here, as well as some glue squeeze out that we need to clean up. And because we're doing this unsupported, I'm just taking very light cuts. This mandrel is rigid, but you will still get chatter. And you can bite yourself in the butt by taking too much of it. Almost through that extra bits. And then I do like to put on some extra eye protection over my normal glasses when I do knock out these little metal bits. And before we do that, let's get our live center pulled up real quick. Alright, and we've just got everything kind of trued up so that we can flip this back around and drill out our end here and get that threaded for our finial. Since we already have the 5/8 collet in the collet chuck, we'll go ahead and just clean up our body as well. This one is honestly a little less necessary to clean up because we don't need to do any more like drilling work on this at all. Everything else that we need to do on this piece is going to just be shaping. But we'll give this a quick little pass. Actually, while we're here, we might as well just shape this body. So we'll do that. I'm gonna grab my mask. As you can probably tell from the speed at which I'm moving through this wood and the way these shavings are coming off, well, maybe you can't, but if you can, cool. But if you can't tell, the reason it's taking me so long to do this and why these shavings are so kind of wispy like that is because this is an extremely hard wood. Osage orange is pretty famed for its hardness. And yeah, it can definitely eat through tools. I may actually have to turn my carbide insert here in just a moment. But we're going to take another pass or two at this and continue shaping this down a bit. Oh, beautiful. All right. That'll probably be good for shaping for this, at least for now. We'll wait to do any like sanding, especially any major sanding or finishing until we're at that sanding and finishing stage. We're just going to break down this corner a little bit for some comfort. And see how we're looking. A little bit of a tight fit down in there, but that is not always the worst thing. But yeah, I think this is going to look really nice. We're not done shaping. We did not actually finish the end of this. So before we forget to do that, let's actually toss a little bit of lubricant on that. There we go. That will be our body. I don't usually make pens to post. I don't really think that it's necessary, especially with a pen, you know, this length. So this will be good. Next, let's get so for now, I want to do a through hole with a 9mm drill bit. Actually, now we should probably just go from the other side. I do need to drill 10mm a little ways from this side as well. So we're just gonna go ahead and do everything from this direction. And then as far as where the 10 millimeter needs to go to, I want to come with that till I'm just past like the shoulder here, so maybe like 53 millimeters in. Actually, we've already gone like 54 with our max depth, so we're probably actually fine. What we'll do before we do any other shaping on this is we'll finish our section so that we can get everything screwed in, and then we can test our fit. But let's flip this guy around and get that threaded. So we have a nice, pretty well perfectly centered hole there, which you want to see. We are going to come in and relieve this corner, this edge a little bit here. And this will also get an M10x1 just like our section threads. We don't need to go as deep as we've gone with this, but I don't really see a reason not to just thread the entire section of threadable material in there. And we're good to go. We can just test with the section really fast. Beautiful. Alright. I think actually the next step we may want to take before we do anything with this section shaping is just knock out the finial for the cap here. For the finial thread, 6 or 7 millimeters is usually plenty. Let's go 7. Actually, first, let's clean off our face.
And this 7 millimeter long tenon will need to be 10 millimeters wide, just under. And this one, since we don't need a through hole for our cap, will have to be hand cut. And then, like, I know right now that this is too wide, but I do like to stop when I start getting close and just check, and that kind of gives you a good visual reference of just how much more you might need to take off. Obviously, quite a bit of shaping to do, but I think this is going to turn out to be really kind of a neat pen.
Next step, let's knock out shaping our section so that we can get that test fit with our nib and see how much, if any, we need to drill into the tenon of that finial so that we have room for our nib. So one of the nice things about these Turner's Warehouse mandrels, or a couple nice things about this section mandrel particularly, is it does have a little 60-degree dimple on the end for live center support, which is really nice. This is stainless steel, obviously, but it is still going to be a little bit flexible. So having that additional rigidity of tailstock support is huge. The other thing for this particular pen is that the little neck down right here from the 1/2 inch where the collet holds down to this little shoulder area. This is pretty much exactly the dimension that you want to have for a 13 millimeter threaded pen. And so we can pretty much just use this as like a bushing on a kit pen and know that that's where we need to turn down to for this pen to be good. Now, there's still not a lot of room to work with in here. But as long as nothing's rubbing, we're good. So I'm going to toss my mask back on and we're going to shape this guy down real quick. I am still going to set my calipers for like 12 millimeters exactly. We have a 12.2 millimeter hole, so if we go straight to 12, we should be all right, especially after we sand and polish. Alrighty, let's see. I think that's gonna be kind of smart. Alright. Yeah, so I don't know how well you'll be able to see in there, but the tip of the nib comes up a little ways into the cavity there. What we'll do is we'll screw this down slowly. That's where we hit. So we'll probably want to go like 3 millimeters into this with like a 7.5 millimeter drill bit, and that'll remove enough material there for us to get over that nib without touching it and give us space for everything in the cap. That should be plenty. Maybe. Might need a little bit more actually. Let's just go a little bit more just to be safe. No reason not to. Yep, that should be plenty. We'll quickly just double check. Shouldn't have taken this apart just yet. Yep, perfect. So, we can move on to shaping our cap. Alrighty, and for this, there is one very important dimension, and that is going to be up here at the transition between the wood and the finial, where the clip is going to be. We want like a 13.4, 13.5-ish millimeter diameter, because we do want a teeny little bit of stick out for the band on the clip. I find trying to chase a perfectly flush fit all the way around is next to impossible. And rather than having the clip be recessed a little bit and having to deal with sharp corners or trying to knock down these corners, I've found, in my opinion, it is better to let the edge of the ring of the clip extend just like, 0.1, 0.2 millimeter past the edge of the wood and the resin there. And that gives you a little bit of something tactile to grab onto when you're pulling it out of a sleeve or a pocket or something. And it also gives you a much more uniform feel all the way around. For this one, I think I am going to turn around my cutter insert. Those corners I've been using are a little bit dull, so alright, so that may actually have been a little bit too deep for what I'm thinking here, but we will see. So we just, I think we're in a good spot. Gotta double check and make sure everything's still recording periodically here, but I think we're doing pretty good so far. We got a little bit more that we need to take off up in this area. I want to leave this pretty much alone for now. I think this is going to be perfect down here. And then, yeah, we just need to bring this down just a touch more. 2 or 3 passes maybe. Some nice light ones. Alright, I think that'll be good enough. Anything else that we need to do, we can finish with sandpaper. So let's get this guy parted off, and then I gotta go grab some packages from the mailroom, I believe. We're about flush everywhere basically, so when we do our sanding, we'll be able to bring things just down past flush. I think this is going to be a really nice looking pen. Yeah, that should be really handsome. So I'm going to take a break for a minute and go grab some stuff from the mailroom. I have a package of blanks that just came in. And then I'm going to clean up a little bit here and get set up for sanding and finishing. This is going to be a very, very cool one. So thanks for sticking with me so far. I know this is a long video or probably series of videos. I don't know if I'm going to upload all of this in one go, but we shall see. So catch you guys in just a few more minutes. And we're back. As you can see, we've got our cap set up here, ready for some sanding. We will get out our water and some 800 grit sandpaper. And actually, oh no, we're not going to be using water. I lied. We got wood here. So we would like to use mineral oil for that. And yes, we'll start with 800 grit sandpaper and then move on to some polishing waxes and likely end with good old friction polish. That has been my go-to since I got it a few weeks back. It has just been making the wood pens look incredible. That is perfect. We're going to get a little touch right here. Alright, that is exceptionally smooth. Let's move on to, actually I do need to be right back. I have to go get my big old new package of shop towels so that we can continue with this. But we're doing good. Oh, it's literally so smooth. I wish you guys could feel this. Alright, I found these blue shop towels to be the best for finishing type stuff. Now I don't generally always like to use these polishing waxes on resins. They tend to build up quite a bit of heat, and compared to acrylics and then also especially like wood, these resins do not have the same level of heat tolerance that the others do, and so you can get warping and similar issues. But for something like this, I've found that they really are the best solution. I don't like using the Zona papers with oil as the sanding lubricant. I much prefer the Zona papers with water. And so for these pens like this, where I'm just finishing the wood with some sanding and the friction polish, I would much prefer the waxes. Yeah, for resins, what I typically do is sand with the Zona papers, wet sand, until I've gone through all of those grits, and then I use the Meguiar's Plastex polish. Usually gives me a really, really nice finish. For this, we're going to go through the full range of the Micro Magics here, mainly to get this resin up to a fairly high scratch-free sheen. It's not going to be crazy glossy when we finish with these. That's the one issue with the resins particularly, and this finishing method is it doesn't get quite as glossy as doing things the, call it proper way. But what this will do is it'll give us a really smooth base for putting on that friction polish, and that is going to give us a crazy high sheen. Now the other benefit of this too is we are very highly polishing the wood itself, which means we will have a very, very smooth base for the wood as well, and that's really going to give us some crazy depth in this particular stuff. I can already see with it spinning, there's some pretty deep flashes from the chatoyance in this. Osage orange is a pretty high chatoyancy wood. It's not a crazy high figure wood in my overall experience thus far, but it does make a very nice bright flash when it's been highly polished. It's also extremely hard too, so this will be a nice, tough, durable pen. As far as this process, we could probably stop right now and do our Mylan's sanding sealer at least. However, I think I would prefer to go all the way through this. We'll then sanding sealer after we rub things down with isopropyl to remove the rest of that wax. And then we'll do our sanding sealer. One more coat with this number 3. And then our friction polish. You can actually see, like, this is a fairly high shine already, or hopefully you can see that, but it's not quite where it could be. Nice thing about that friction polish too is it will fill in some of these scratches that you can kind of still see here, so that will be very nice. But a lot of that sheen just now was from polished, kind of burnished wax in there. So yeah, you can see very smooth on the wood. Oh my gosh, yeah, that's gorgeous. We almost don't even need to do anything to this. We are going to, but we almost don't need to. And then, yeah, this is going to be a two-step finish. The first is going to be the sanding sealer. This is going to seal in pores in the wood. And this is a lacquer-based sealer. It dries quite quickly. We're just going to slowly rub that in. We're going to give that a couple coats. We're not currently worried about the evenness of this coating at all, because in just a second here we will be cutting this back again. We'll load back up with a little bit more of this stuff. And then this is going to cut back and help polish that sanding sealer coat. Even things back out and give us a really nice base for getting our friction polish in there. And really, we could probably actually just leave this here as is for now. I don't want it. We want a nice, super high gloss, but still natural feeling finish. So I'm going to turn this up to about 1500 RPM. We were at about 800 before. And we're just going to get a little bit there. Rub this on. And then we're going to get some good friction going. And you should be able to see that start to shine right up. We do want to build up enough heat that it does become a little bit uncomfortable to hold our finger on there. That heat, ouch, that heat helps set the finish. I'm going to come back in with another little bit. Rub it on and start to polish. Now we'll do one more. I think 3 is plenty for this. The nice thing about this too is once you have heat set this stuff, it's fairly handleable right off the bat. All right, and be able to give our finger a little bit of a rest there. I don't know how well the camera can pick that up if it's getting any of that chatoyance, but you should be able to see at least some of that sheen and shine on there. And we're going to start the same way. 800 grit sandpaper followed by our polishing waxes. did drop back down to a 600 there on accident, but not a bad thing. It actually gave us a little bit more aggressiveness to really smooth out the body here. Now we'll do our 800. There we go. Goodness. Next up, let's get these waxes done. Yep, once that sets, that's going to be very, 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 very nice. Now, last but certainly not least is our section. And for this, since we are doing all resin, I will do wet sand with 800. Our surface finish was already pretty nice off the tool, so we don't really need to do too much of this sandpaper sanding. And in the spirit of contrast, which I would say this pen is heavily built around, let's go ahead and just do a kind of like a semi-matte finish on the section here. That is A, because I'm a little lazy sometimes, and also B, because I do enjoy how a matte finish feels for a section. It's a little more grippy, it doesn't feel quite as plasticky sometimes as a full polish does. But I don't always do it. This particular resin is one of those ones that just does look really good with a matte finish on it. There's enough texture in it to look nice, even if it's not completely polished up. You get a little bit of a sheen, you get some of that chatoyance from the mica powder, but it gives you a little bit more grip doing it this way. So, this guy is handleable. That's good. What I may do is do a little handling of this today and let this dull down a little bit. I find these shellac finishes do tend to do so. over time. And then tomorrow I'll put another coat on. And I do think that if I do another coat, I'm going to run that 8mm drill bit back down through just by hand to widen this out a little bit inside. It is a little too tight. This is the tightest I've ever felt this guy, so. There we go. That is our basically finished pen. I will engrave my logo on the clip with the laser and do some photos at some point as well. I'll probably shoot for taking photos of this before I get this video posted so that I can include those at the end here. But hopefully you were able to learn something from this, or at least had a entertaining time. For the most part, this is not a how-to. This is how I make a pen like this. So thank you so much for tuning in, and we will catch you guys on the next video. Peace.